Hey, it's Joe. How's it going? Today I wanted to walk through building a custom unit that is going to be a polyphonic, a 4-note polyphonic round-robin sample player. This kind of came out of a chat on the forum with community member B Particle, who wanted to build this up, and it actually turned out to be a pretty interesting build, so I thought I'd make a video about it. And so what we're going to build, I'm just going to play an example here. So this is a polyphonic playback, but it's round-robin style, which is kind of I guess an older style of polyphony. So you don't really, send it, you can't really send it a chord or multiple CVs. You're kind of sending a single, a single string of CV, one gate signal, one VO signal. You don't really send it a chord, you send it individual notes, but up to 4, the notes kind of ring out. So if you play one note and you play a second note, that first note kind of continues to ring out while the second note's playing. So you can kind of build up a chord up to 4, just like that. And when you get to the 5th note, it cuts off the first note, or kind of steals it away. So this is what we're looking to build. I'm just showing you here. We're currently on version 0.3.15 of the firmware, and we're going to go ahead and reboot the unit here. I think the best way to show this is just kind of start from scratch, because there are a couple challenges that come up along the way, and I think it'll be clearest to see those. So here we go. The original unit was actually not a custom unit. It was built out of a global chain and a unit chain. Today I'm going to build them as a custom unit. One to just kind of keep it all together as one neat package. And also I think there's maybe a couple advantages to building it as a custom unit. So here we go. We'll just start off with an empty custom unit, Mad Oven. Let's go ahead and rename this. And we'll just call it 4 Poly. All right, first thing I'm going to do here is add a couple of custom controls. And the first one, we're going to make it a linear control. And I'm going to call this one Count. So we'll come back and spend some time on that. The second control, we're going to make this a pitch control. And we'll just simply call that VO. And for the last one, we're going to insert a trigger control. And let's just call this one TRG trig. All right, cool. So let's just go ahead and make a couple of assignments here. I'm going to go ahead and assign my trigger, which I've got a trigger signal coming in on G1. Actually, it's a gate signal, but we're going to kind of convert it to a trigger here. And we'll go ahead and assign the VO, which I've got coming in on A1. Cool, so I think those are in pretty good shape. So let's go in and define this count parameter. So with any linear control where I'm going to build a subchain, usually the gain ends up getting set to 1 so that it actually controls this, and we can use this as a reference further down in the chain. So I'll go ahead and set the gain to 1. And since this is going to be polyphony 4, we basically need something that can count to 4, and that's going to kind of switch between the different sample players that we're going to use. So in order to do that, I'm going to start off with a custom unit here. This is not my custom unit. This one was built by the man himself, Mr. Orthogonal Devices, Mr. Brian, and it's called Count. So you can kind of check out how this works. I'm going to go ahead and assign a trigger here. It was set to A2 by default. I'm going to use my local custom control that I just set up, TRG. And let's see if that's working. It looks like it is. So you can kind of see what's happening here. This custom unit, every time I send it a trigger, if you kind of look here at the graphical display, every time I send it a trigger, it increments the voltage by just a little bit. So we need to customize this unit a little bit more. I really only want this thing to count to 4. There's also a reset control here. So if you fire this, it's going to reset the voltage to 0. I don't really want to have to use that. I've got my CV source is coming off of a keyboard here, a CME X key 25, and it's not going to be very convenient for me to send a reset signal every 4 triggers. So I kind of want this to just operate on its own without having to send a reset, and I think that'll be most flexible. If you take a look at this thing, it's got a step parameter on it, and this is sort of a multiplier or a gain, right? So if I set this step and now we watch it again, you're going to see it's going to take fewer triggers to get this thing to advance from 0 to 1. So that's better, but it's still too many. I really only want it to take 4 triggers before it gets up to from 0 to 1. So let's dive down into the count unit here and kind of see how this works. So we've got an aliasing saw, which is just a linear progression. And normally it goes from -1 to 1, but Brian has some adjustments in here, an offset and a level, which instead kind of makes it go from 0 to 1 instead of -1 to 1. But you can kind of see what happens when we send it a trigger. It's sitting at the F0 is sitting at 0 hertz right now, so it's stopped, and it's just sending out kind of whatever voltage it stopped at. When we send it a trigger, it just really briefly, for the the length of time that trigger is high, sets the frequency to something above 0, and it advances the phase of that aliasing saw, by just a little bit, which causes the voltage to increase by a little bit and then stop at that next point. So what we want to do now is, you can kind of see here, if you look at F0, actually let's dive down in here. So we've got a linear VCA, and we've got this step parameter that you saw up top, which I set to 5, is down here. So this is really just kind of sending out, a value of 5 right now, so that's a multiplier. So 5 is one multiplier, and then we've got this 390.6, and that determines, for the length of that trigger signal, what are we going to set this F0 to for just that brief amount of time to cause it to advance. So what I want to do is figure out, a gain right here that's going to allow me to send triggers such that I only have to send 4 triggers to make this thing advance, from 0 up to the final voltage, and then kind of reset itself. Let's see here. So how are we going to do this? So I've kind of figured out some of the math behind this, which was a little complicated, but it's actually pretty easy once you figure it out. So I'm gonna try to get this calculator into view here. Hello, calculator. All right, hopefully that's okay. So it turns out this trigger signal that's being sent by the custom unit, it actually depends on the version of your firmware that you have connected. So I have the 48 kilohertz version, 48,000. And it actually turns out that this trigger is just being sent for kind of one sample length. So if I invert this 1 over x, I find out, how long that trigger stays high is, it looks like 20 microseconds. So what I want to do is I want 4 triggers to advance this all the way through its progression. So I'm going to multiply this by 4. So that'll be kind of the total length of time that I want to have a trigger high in order to progress this all the way through. And I'll reinvert that, and that gives me 12,000. So really I need a gain of 12,000 on this thing. But you'll recall we had that step parameter. This thing doesn't, you can't set this all the way up to 12,000. The gain doesn't go that high, but we do have that step parameter in there that would set to 5. So that's kind of another multiplier. I'm going to go ahead and divide this by 5, and I get 2,400. So that's the gain that I'm going to need to set on this F0 parameter to make it work like I want. Let's try it out. So there's a gain of 2400. Let's go ahead and just fire a reset here to send it back to 0. And I'm going to send some triggers from my keyboard. And so that's working out perfectly well. Now it's just taking 4 triggers to advance it all the way through. You know, I've got a trigger stop at 0. It looks like 0.25, 0.5, 0.75, and then it resets back to 0. So that is exactly what I want. Now I should be able to kind of detect this and reliably, you know, figure out where this count is at. Cool. Okay, I think that concludes our discussion of the count unit. Let's actually go set up some stuff in here. So what I ultimately want, you know, for this 4 poly is, you know, kind of 4 sample players that are, their outputs are mixed together. So I'm going to start with a mixer. And just because we could have up to 4 sample players playing, I don't want anything to clip, so I'm just going to, you know, reduce the gain of this kind of out of the get-go. I'm going to bring it down maybe 3 dB. And let's jump down inside this mixer, and we'll put in a sample player. And we're going to assign it a sample. Select from pool. And I'm going to use this E guitar A. This is an electric guitar on an A note. So you can see in here, it's kind of a long sample. This works better with longer samples because we're really just going to let these ring out for their entire duration. So if they're a bit longer, it you know, kind of helps to create the 4 poly effect. Okay, so let's go ahead and assign our VO. And for that, I'm going to use the local VO that I set up in my custom unit. So this is my custom control. And also let's assign the trigger to the local TRG. So at this point, I should be able to kind of play my keyboard, but this is just going to be kind of monophonic. So each time I'm kind of re-triggering, you know, the sample. So we all know how that works. All right, so what I want this to do, instead of triggering every single time I send it a trigger, I just want it to trigger 1 out of 4 times. So in order to do that, we're going to use a bump scanner unit, which is kind of a mapping unit, to figure out, you know, are we on the right version of our count, or on the right iteration of our count. So the first thing I want to do is I want to block this trigger signal. To do that, I'm going to put a linear VCA in here, and now when I send these triggers, that's not letting them through at all. I want to selectively let them through. So let's set the gain on this to 1. And now we're going to come down inside, and what I want to look at to control this VCA is my count. And I told you we're going to use a bump scanner unit, so let's go ahead and insert one of those. That'll be the input to our bump scanner. So if you don't know how the bump scanner works, I'm not going to cover it in too much detail. I did make another video on it, so feel free to watch that. It's a little more in-depth explanation. But basically, this bump scanner is going to put out 1 of 2 values. It's either going to put out a 0, or it's going to put out whatever the height is set to. So for me, it's going to be a 0 or a 1. So we've just really got a binary output here, 0 or 1. And the way we're going to determine whether it's a 0 or a 1 is by looking at its input, which is count. And we're going to determine if count falls within the bump scanner's window. And the window is determined by the center parameter and the width parameter. So this is kind of the first mixer, the first sample player. And actually we want it to, we want this one to fire when the count is at 0. So the center is already set up correctly. But the width is set a little bit high in this case. We can make the width, you know, quite a bit smaller. So maybe let's just start with something really small, like 0.05. So if the input count is between, I guess, minus 0.05 and plus 0.05, then this bump scanner should put out a high output, 1. Otherwise, it's going to put out a 0. So we're doing some selection here. So let's check out how that works. So right here we're at 0.75. And let's put the scope on this. And as I advance to the next one, we should see this go high. And it does. If I send another trigger, it should go back low. So I think that is all working as expected. So let's just take a look here. So we're at 0. So here's something kind of funny that's happening, right? I actually want this to, I want this sample player to be triggered when my count is at 0. And it looks like it's actually triggering and playing the note when I'm at 0.25. So we got to think a little bit about why would that be. If you think about it, we've got this count unit up here that's receiving a trigger, TRG, and we've got my sample player up here that's receiving the same trigger, TRG, and we've got just a little bit of a timing issue, right? So they're both receiving both this VCA, the trigger being fed into this VCA, and the trigger that is feeding my count custom unit are both firing at the exact same time. And that's not going to really work out too well, right? So, you know, let's see, it's going to be a good view here. So what I'd like to do here is introduce a little bit of delay to just give, you know, this trigger, the count, a little bit more time to react, a little bit more time for the VCA to open up before it actually fires this trigger into it. So the perfect unit for this is the new micro delay. So this just is a 100% wet delay. And I'm just going to give it, you know, just a little bit of delay time here, 7 milliseconds. And that way, when this linear VCA opens up, when the count is 0, you know, this is going to wait just 7 milliseconds, and then it'll fire that trigger in there, and that'll just give it a little bit more reaction time. So let's see what that does and if that works. So back here, we're at 0 now. We'll advance the trigger, so we're at 0.25, 0.5, 0.75. As we go back to 0, I would now expect to hear a sound. Cool. That is exactly what we want. So, we've got one more slight problem here, and that is around the volt per octave input. So, the volt per octave input is tracking, but I'm just going to play a series of notes here and kind of watch what happens. So we're actually only triggering the sample player once every 4 triggers, but the volt per octave kind of continues to follow for the other 3 triggers, right? So right now we've got kind of a funky legato thing going on, right? Which is kind of a cool effect, but it's not what we're going for here. We want, you know, essentially for this sample player to maintain the pitch, you know, until the next 4th trigger is heard. So we're going to have to set up something kind of similar on the volt per octave, right? So what we'll do is come in here, and we want something that's going to hold this VO constant until it's time for it to change. So for that, I'm going to use the good old sample and hold unit. And we also want this to pay attention to the local custom unit control trigger. But we want a very similar setup to what we have on the other trigger control. So actually, let's just go steal that. That's the easiest way to do it. So we'll come in here into the trigger, and I'm just going to hold down Shift, and I'm going to copy these 2 units, come back into the VO. Let's just paste those in there. So we've got a very similar setup here now. Now let's play a series of notes and see what happens. So I'm playing 4 different notes there, but you're hearing that this is only triggering, and it's holding its VO value all the way through. So I think this is working perfectly now for one sample player. So I think it's pretty straightforward to set the rest of these up. What we're essentially going to do is just make 3 more copies of this. And really the last step here, we just need to go in and adjust these bump scanners' center values so that they're triggering at the right times. So let's go into mixer channel 2, and we'll start with the VO, drill all the way back down to our bump scanner. And for this one, we want the center at 2.5. Remember, our stops were 0, 0.25, 0.5, and 0.75. So we do it on the volt per octave. We need to make that same adjustment on the bump scanner for the trigger. So I think that one is done. And now we'll just make the adjustments for the other two mixers. This last one here at 0.75. All right, I think that's it. So let's come back up to these mixers, and let's see if this is working. So. Looks like it is. You can kind of see each mixer channel as I send it a different trigger up to 4. Kind of fires off at its own time. It sounds exactly like we want. So one of the advantages, I think, of putting this inside of a custom unit, I've got my trigger control at the top, I've got my VO control at the top. This is actually an A guitar sample, an A string. So when I play my C note on my keyboard, I get an A sound out. This makes it real easy for me to transpose it. So if I just roll this up to 300, now I get a C note out, like I expect to on my keyboard. Cool. Well, I think that's it. I hope you have enjoyed, and if you have any questions, feel free to post on the forum, and we can talk about it there. All right, take care.